Okay, let's look at how you find the area of a triangle. Now before we do that, let's just review how to find the area of a rectangle. I've got the formula written over here. The area of a rectangle you find by taking the length times the width. So if I look at the blue rectangle that I've got drawn over here, I've got a length of 1, 2, 3, 4, 5, 6 units and a height or width of 1, 2, 3, 4 units. So the area would be 6 times 4 or 24 square units. And that makes sense. If I were to count up the squares in here, I've got 24 of them. But now what I'm going to do is I'm going to create a triangle inside the rectangle. Let me color that for you. So now what I'm interested in is how many units, how many square units would that green triangle be? Well, if you just look at it, it's half of the rectangle. And sure enough, the formula for the area of a triangle looks almost like the formula for the rectangle. Except instead of calling it length and width, we call it the base and the height, and then we take half. So basically the area of a triangle is the base times the height and then half of that. So this triangle has a base of 6 units and a height of 4 units. So in my formula I put the base is 6 and the height is 4, but then the 1/2 is part of my formula. Let me do that quickly. Sometimes I do the 6 times the 4 first. That's 24. And I'll write that as a fraction. So we end up with 24 divided by 2, there it is being cut in half, multiplying by half, dividing by 2, same thing, and sure enough we end up with 12 square units. So the area of that triangle is 12 square units. I've got my little button over here where I can click on it, and sure enough, if I look, it says it's 12. Now if you notice, I've redrawn the triangle so that it doesn't cut it directly in half. It cuts it into 2 separate pieces here. But it turns out if I click on the measurement here, the area of this triangle is still 12 square units. The base is still 6. The vertical height, now that's what I'm looking at, is 4 units. So I'm still taking 6 times 4 and then taking half of that. If you were to take these 2 extra pieces here and put them together, what you would find out is they would fit precisely on top of the green triangle. So it doesn't really matter how you draw the triangle inside of the rectangle. I'm showing one more example here. This one's probably even a little bit more obvious. If I click on measurement, I still have 12 units. So what I've done here is I've cut it up a different way. If I took the 2 pieces that are not part of my triangle but are part of the rectangle, I would be able to fit those directly on the green triangle. So that green triangle is still half of the 24 square units that make up the rectangle. I wanted to show you what this often looks like when you see problems like this in a textbook and other places. So I've drawn this triangle here. I've marked the base and then I've marked the height. Now notice there's a dotted line in there. All that's showing is what the total height, or the vertical height we call it, of that triangle is. Oftentimes they'll put a little square down here to show that that's at a 90-degree angle. So this triangle has a base of 10 and a vertical height of 6. So for my formula, I've got 1/2 the base times the height. I did the base times the height first, which is 60. And then I took 1/2 times 60. I worked with it in terms of fractions. You're really just taking half of 60. It turns out to give you 60 over 2, which sure enough is 30. Just to give you 3 other ways to view this. So if you have a base of 10 and a height of 6, you can think of it as 6 times 10 is 60, and taking half of that, which is 30. Or you can take 1/2 of either the base or the height and then multiply it by the other. For example, if I took half of the base, which is 5, and multiplied by the height, 6, that would be 30. Or if I took half of the height, which is 3, and then multiplied by 10, that's still 30. So all 3 of those methods work.